Can you like move over like 3 inches? Exactly. Exactly. Thank you. Okay. The agenda today is we're gonna describe graphs in many different ways. That's our goal. Yesterday we talked about defining functions. What is a function? What is not a function? So, number 2, if you pass a vertical line test, maybe I'll just put a bunch up here. Here's some that pass. And then over here we can put some that fail. I'll do lots of examples. And these are all X and Y. And they all have arrows. Okay. Alright, so what are some examples that pass? You could do like random points. And that passes a vertical line test. You could do a nice straight line, and that passes a vertical line test. You could also do a squiggly line. And this passes a vertical line test. All of these options are good to go. These could be functions. Okay? You could do any example. You could have a different one as well. Any questions about the passing the vertical line test? All right, here are some examples that fail the vertical line test. This one is not a function. That one doesn't work. This one, not a function. This one, not a function. Okay. So this one fails because right here, these 2 points are stacked vertically. Stacked is no function. This one fails because it hits twice here, or maybe here, anywhere. And this one fails because it is a vertical line. So those are all examples of not functions. Questions on that? All right, I need to check your assignment. Okay, so when I look at the x-axis, it goes from 0.5 to, I think that's 1.75. Yeah. So it's going from 0.5 to 1.75. Then I gotta look at the y-axis. The y-axis, the lowest value is 0.25 and the highest value is 1.5. So you're looking at how wide is it and then how long is it. And it's a range, and that's because the points are connected. Another thing I want to say is that I didn't underline these inequality symbols because what I see here is an open circle. So because it's an open circle, I just did regular without the line underneath it. The closed dots, I had lines in the symbols. The open circles, I don't. Okay. I didn't really get to this yesterday, independent and dependent variables. The number of quarters you put in the meter, the amount of time. The quarters is independent. And the time is dependent. The amount of time you can park depends on how many quarters you put in. But you could park there all day. Does it affect how many quarters are in your pocket? No, the quarters in your pocket are just there. The amount of gas in a tank and the amount of time spent driving. This one they switched around. The amount of gas depends on how long you've been driving. How long you can drive depends on the amount of gas. Alright, so your gas is your independent, and the amount you can drive, time is almost always independent, but this is actually the amount you can drive is dependent. A cell phone plan costs $30 for each line. Yeah, that's a function. Yes. The independent variable here is the cost depends on the number of phone lines. The number of lines is independent and the cost depends on how many phone lines you do. If you can have a maximum of 4 phone lines, what is the domain and range? Okay, so 0 lines cost how much? $0. Okay. 4 lines cost how much? $120. So let's talk domain and range. So, your domain is the number of lines. Your range is the amount of money you end up spending on the number of lines. This is, you can spend between 0 and 120. So you can purchase between 0 and 4 phone lines, and that's going to cost you between 0 and $120. Yeah. And then here's 18. The independent variable is the number of miles you drive. The dependent variable is the cost. No, let me switch that. The cost depends on how many miles you drive. So your range is between 0 and $72.80, and your domain is you can drive between 0 and 20 miles. Because it says you can drive at most 20 miles, and then you plug in 20 and you see how long, not how much that costs you. It costs you $72.80. So I want you to read that and really think about it for a minute. You've probably never done domain and range like that. Maybe you've talked about domain and range before, but probably never like that. Good job. Big foot. Okay. Good. Flip. You have it? Thank you. Okay.
What is that? Where'd you get that from? What's the purpose? Exactly.
Alright guys, I have a handout for you. If you want to flip really quick to chapter 3.2, page 190, I have a handout for you for this because it was difficult last year for students to remember this. I'm giving you a handout.
I'm stealing your paper. Yeah, just make a pile in the back if you have extras. Alright, what page should I set? Okay, good. Make sure you put on here, this is from page 190. It's chapter 3.2, and yours says key ideas and graphs. So the first two, I believe you already know and are comfortable with. Take that off. You have to get a black one. Check that.
Alright, so the first key characteristic that you must know how to take out of a graph is the x-intercept. The x-axis. There's one. So if you guys have a highlighter, go ahead and get that highlighter out. Go ahead and get your highlighter out. This is your x-intercept. There's an important note here. You guys make this note, please. Make this note. That an x-intercept always has a y value of 0. Yes, always. This is something I'm currently talking about in Algebra 2. They're finding x-intercepts of parabolas, and we're setting the equations equal to 0, and they're not sure why, and it comes right back to this day in Algebra 1. X-intercepts always have y values of 0. Okay, y-intercepts. If you want to highlight the y point on this second one, this is the y coordinate where the graph crosses the y-axis. And so let's make a similar note. A y-intercept always has what? An x. Yes, always has an x value of 0. There's always an x value of 0 on the y-intercept. So it's interesting how it's called a y-intercept, but the x is 0. That's because it's right in the center, right? This one's called an x-intercept, but the y is 0. It's like the one you're asked about. Just know the other coordinate is 0. And intercepts are brought up a lot. So knowing that fact is really helpful. Okay. Now I'm not sure if you guys got to this last year. But before last year, I never taught this in Algebra 1. So this was new last year. Positive, the graph is called positive. This is a characteristic. It is called positive anywhere where the graph is above the x-axis. Above the x-axis. So you describe it using the x value. That's what's difficult about it, is you describe it using x values. So this is, I'm going to highlight this whole area. Up here is positive, right? But we actually have to make a list and actually say, where is this graph positive? So it's positive here. So I'm going to say it's positive when x is between -4 and -1. That's the part that's tricky. It goes positive again. It's positive in 2 places. It's also positive over here. So it's going to be positive again anytime x is greater than 2. So this particular squiggly line, this is actually a cubic graph, is positive in 2 places. So you have to describe both places. It's up there. It's not positive over here. It's not positive in the middle. Specifically positive in those 2 places. Questions about that? It's on the x-axis. See, she's looking at it. That's exactly a good question. Because your instinct, a human natural brain, is going to tell me y values and not x values. That's a 1, that's a 2, that's a 3, -1, -2. All right, negative. We're negative anywhere the graph lies below the x-axis. So I'm going to highlight below in yellow. This is the negative side. And you'll be asked to describe where is it negative. When you describe it using x values. Not y values. Focus your eyes on the x-axis. So it's the same graph, -1, -2, -3, -4. 1, 2, 3. All right, so this time, maybe I'll just do like gray blue. All right, it's negative right here. Down here it's negative, and it's also negative here. So yeah. Okay, so for if we're below the x-axis, on this side, that's what, a -4. So I'm going to describe that as x is less than or equal to -4. And in the middle, x goes between -1 and 2. Yeah. All right, our last descriptions is increasing and decreasing. I know from last year it's very difficult to figure out the difference between positive and negative and increasing and decreasing. We're just thinking it's the same thing. It's actually quite different. Increasing is any area where the graph moves up as x moves to the right. So the key here is that you read left to right. All right, so I'm going to show this in red again. This is increasing. And then right here it's increasing. It's increasing all over the place except for this one little downhill slide. Right here it's decreasing. So we would describe it like a roller coaster. It's going uphill, decreases downhill, and then it goes back uphill again. Increasing and decreasing. So again, I'm going to describe using x values. Okay, so gosh. Kind of in the middle there, unfortunately. So it's increasing over here. I'm gonna stay with red. So what x value is that? This is -1, -2, -3. So I'm gonna say it's increasing when x is less than -3. And then I'm just gonna call this x value 1. It's increasing again when x is greater than 1. Over here it's increasing, and over here it's increasing. Alright, next to that, we will then describe where a graph is decreasing. That's where that graph is going down. So it goes from here to here is when that roller coaster is downhill. Again, I don't care about y. We're talking about x's. You describe the x values, not the y values. The reason for that is because mathematicians are more concerned about independent variables than dependent variables. So they want to know what x is doing. So x is decreasing anytime it is between 1 and 1, 2, 3. Negative 3 and 1. If it's asking about range. What's that? No, same, yeah. You read left to right. Alright, and behavior. In the end, you describe if the arrow on the left goes up or down, then the arrow on the right. So I'm going to use this same graph here. I just didn't reprint it. Our graph looks like this. Okay. So the arrow on left goes down, and the arrow on right goes up. And that is describing graphs in lots of different ways. All right, when you're ready, you're going to page 189 to 191 and do 147. I'm going to do them too, but you guys start before me.
Do it. You won't? No, that's fine. The whole way? Exactly. Alrighty. The ancient scrolls are saying about like, no, not that one. I'm gonna write the ancient scrolls. Oh boy, it's the ancient scrolls. So
Okay, listen. It's not gonna help you to say copy what I do, but here we go. I waited. You guys just talked. So I guess we'll just copy what I do. Okay. Try it. Yes. All the time I go really fast. It's a little bit of a defense mechanism. If I hear you talking about anything that's off task, I'll just start working up here because you're quieter when you're just copying what I do. But you're not learning anything. You're quiet, but you're not learning anything when you're copying what I do. But if I give you time to work and you just talk about whatever, you're not learning anything that I do. Okay? If you're silent copying what I do, like the 10 people who are pretty good at this will figure it out. But the rest of you are just copying words. You don't know what you're writing. Right? I know what I'm writing. But if I can't get all of you on board, maybe I just do those 10. I don't know. Go ahead. Yeah, you're for sure gonna get confused if you don't even read the question, right? Read the question, what's it asking?
Which ones are we doing?
1 through 7. So you're asking me?
Yeah, we'll do 7.
189 to 191 number 7.
189.
Alright, sorry if you were confused. My bad. 189 through 191 number 1 number 7. That's what I meant. Yeah. Okay, so when you look at your paper, can you circle the observation?
Yeah.
Okay, start by circling it. Now take a guess as to where it's at. I think 1 around.
Yeah.
This is a 1, and this is a 2. Here's the x-intercept. So 1.5 comma 0. That's an estimate. Good question. Now y'all go ahead and estimate the y-intercept. There you go. That's what we're doing.
X and Y do the same. Or would there be more?
That's true, Tyler. No x-intercept. A flat line never hits an x-axis, so that one is a nut. So that one's a nut.
Okay. The Y is right under. Let's say like 1.2 on the line is exactly right under 2. Negative 2.2. Which one? For number 2, I got negative 2.211. Does it have to be negative 2.4?
Actually, because they actually give you the number there,
Oh.
you can put it. It says estimate, so I would have gone 2.2, right? If you didn't notice it. But since it does tell you exactly, you can go ahead and put it exactly.
Okay.
Okay, I have drawn in the points here on number 3 for you. There's 3 important points there. Yeah, you're gonna list everything. Anybody else know?
12.6.
Okay, we're gonna need the x's first. How do we go? What do we do x's?
Negative 1, 0, and 1.
Yes, there are 3. This crosses the x-axis in 3 places. At negative 1, at 0, and at 1. Good job. And then there's actually only one y-intercept where it crosses the y-axis.
Yes, because we're expanding our house and we're gonna like put it in an outside room. It's gonna be like the junior master. And I want it, and then I want to have like a bunch of cats in there. But it's gonna be my room, you know. And they'll just be their room.
Are you gonna be the cat lady?
Are you gonna let them outside?
No. But like all the cats from outside on the streets, they always come up to me and they let me pet them and I feed them. I didn't used to feed them. I would walk around and they just let me pet them. I got you. I used to have like 12 when I was younger, but they all passed away.
Wow, cat.
Because she got, well, my other cat got pregnant.
Cats are kind of mean. I'm not gonna lie.
Yeah, and my mom's husband's allergic to them. Cats, but we have two cats. So
You trying to kill them?
no, he just doesn't roll in the room. And it's better if I had that.
Alright, here we go. This is complicated. They wrote like a whole paragraph for you to do. And it's like, it's a lot. It's a lot to do here. They make it sound so simple, but they say identify when it's positive, when it's negative, when it's increasing, when it's decreasing, and describe. That's actually 5 things they want you to do on these graphs. It's a lot. So let's do positive first, and then negative. Alright, so you want to look at the green or pink paper. What does positive mean?
Zero.
It's above the x-axis.
Above, so where it's red is above. How do you describe that?
Greater than or equal to 2.
Alright, the negative, I'll color in green, is negative down here. How do you describe that?
Less than equal to 2.
Yeah, on the left of 2. You know, I'm concerned about my equal sign. It can't be the same.
Yeah.
You guys, let's go ahead and erase these.
Yeah, I don't really like them.
Erase it. Just make it greater or less. Don't make it equal to.
I don't really like them.
Right in the middle is neutral. Okay, here we go. So now, where is it increasing and how come it's not the same thing?
The whole thing's inclusive.
Yes, good job. The whole thing is increasing. How do we say whole thing? Let's go with all real numbers. All real numbers. It's increasing the whole time. It's just going uphill the whole way. It doesn't turn and go down. It's never decreasing. For decreasing, I'm gonna write never.
They can do that?
Yeah, this one doesn't decrease. If it doesn't have a curve, it's usually one or the other. A curve or a point. The straight line, it's just going uphill. It never turns. This is the best. Now, end behavior. Gosh, on the left end, it goes down. Left end is down. Right end is up. Jeez, so many characteristics. This never used to be an algebra one. Alright, number 6. Let's not do 7. We don't have time.
Yeah, no 7.
Wait, can we just do it? Don't do 7.
Oh.
We don't have time. We don't have time. Let's just do number 6. There's equal and opposite. Do we have to do 8? No. No, still do it.
Wait,
No, you guys know this isn't your assignment.
this isn't.
This is classwork. You have homework and it's page 193. Do we have time to do this?
No.
Like 3 minutes.
Yeah, we totally.
Oh my
Yeah. It's, I can't take this for granted. I'm surprised how I made it in this class.
No, I'm surprised you got this. Yeah. I'm proud of it.
Why you guys packing up?
Tavish. Tavish.
Oh, why y'all packing
At least look at it. Does it make sense?
up? Stop
It's
stop
simple
packing
for my
up,
brain.
guys.
Brain's okay.
You guys still have 2 minutes.